Evaluate the partial sums, or evaluate the sigma notation. First, we have the sum from k equals 1 to 23 of 4 plus 3k. Let's begin to generate the sum. The first term is when k equals 1. 4 plus 3 times 1 is 7. Plus, the next term is when k equals 2. 4 plus 3 times 2 is 4 plus 6 or 10. Plus, the next term is when k equals 3. 4 plus 3 times 3 is 4 plus 9 or 13. And the sum continues all the way out to the last term when k is 23. Let's determine a sub 23. A sub 23, the 23rd term is 4 plus 3 times 23, which equals 4 plus 69, which equals 73. And now analyzing the sum, notice we have a sum of an arithmetic sequence or arithmetic series where the common difference d is positive 3, which we can see from the formula is the coefficient of k. Also notice 7 plus 3 is 10, 10 plus 3 is 13, and so on. Of course, we could also determine the common difference d by taking any term in the series and subtracting the previous term. 13 minus 10 is 3, 10 minus 7 is 3, and so on. Because we have an arithmetic series, or a sum of an arithmetic sequence, we can use the formula S sub n, which is the sum of the first n terms of an arithmetic sequence, which equals n divided by 2 times the sum of a sub 1 and a sub n. Which in our case, because k equals 1 to 23, the sum of the first 23 terms, because we have a sum of an arithmetic sequence, or an arithmetic series, S sub 23 is equal to 23 divided by 2 times the sum of a sub 1 and a sub 23. And we know a sub 1 is 7, and a sub 23 is 73, which gives us 23 divided by 2 times the sum of 7 and 73, which is equal to 23 divided by 2 times 80. Simplifying, so 1, 2, and 2, and 42s and 80. The sum of the first 23 terms of the arithmetic sequence is 23 times 40, which equals 920. Now we know the sum from k equals 1 to 23 of 4 plus 3k equals 920. And now let's look at our second example. We have the sum from k equals 1 to 40 of negative 8 minus 7k. And just like the previous example, this will be the sum of an arithmetic sequence or an arithmetic series where the common difference d is the coefficient of k, which is negative 7. Again, let's generate some of the terms in the sum. When k equals 1, we have negative 8 minus 7 times 1. Negative 8 minus 7 is negative 15. Plus, when k is 2, we have negative 8 minus 7 times 2, or negative 8 minus 14, which is negative 22. Plus, let's go all the way out to the last term, which is when k equals 40. A sub 40 is equal to negative 8 minus 7 times 40, which is negative 8 minus 280, which equals negative 288. And because we have the sum of an arithmetic sequence where the common difference d is negative 7, we can use the formula S sub n for the sum of an arithmetic sequence or an arithmetic series, which is S sub n equals n divided by 2 times the quantity a sub 1 plus a sub n. Which means in our case the sum is equal to S sub 40, which equals 40 divided by 2 times the sum of the first term and the last term, which is a sub 40, giving us a sum of negative 15 and negative 288. Simplifying, we have 20 times the sum of negative 15 and negative 288, which gives us 20 times negative 303, which equals negative 6,060. Now we know the given sum is negative 6,060. I hope you found this helpful.